together with the steps. So let's find our y-intercept first, right? So we're going to plug in 0 for x, and we're going to get 19 over negative 76. I think that reduces to 1/4 if I remember correctly from last year. So that is negative 1/4. So for our y-intercept, it's 0, negative 1/4, and we can plot that on the y-axis, just kind of estimate, right? It's between points. All right. So then we're going to find our x-intercept. How can this numerator ever equal 0? It won't, right? So there's no x-intercept. Then we're going to take a look at the denominator. So my denominator is 38x minus 76. So we want to know what will make this equal 0. So we would have to add 76 to the other side and then divide by 38. I'm pretty sure 76 divided by 38 is 2. So when x equals 2, this denominator will become 0. So we need to write our domain as x can never equal 2, but our asymptote at x equals 2. So then we can put the vertical dotted line at x equals 2. All right, so I've got so far one intercept and one asymptote. I skip the range until the end. And then my last step is to look for the numerator and denominator compared to each other. Where's the bigger power of x? So where's the bigger degree of x? Denominator, right? This is a constant function. There's no x. And then this one is a linear function. So the denominator wins. And our rule when the denominator wins is y equals 0, right? So my other asymptote is y equals 0. That's why there was no x-intercept, because I have a asymptote along the x-axis. I tried to make it so you could see it there. I'm still going to wait till the end to do my range. But now, anywhere that I have a point, I know that it's going to go through the point and hug the asymptotes. So I'm going to have this elbow go through the y-intercept and then come down on either side to hug the asymptotes. So that's my first elbow. And then I need to find out if my other elbow is in this top right section or bottom right section. So to figure that out, I need to plug one x value into the function to produce an output. I'm going to plug in x equals 3 because 3 is to the right side of this asymptote. So if I plug in 3, I'm going to see what I'm going to get. So 19 divided by 38 times 3 minus 76, all in the denominator, gives me positive 1/2. So at 3, I'm at positive 1/2. So I'm going to plot that point and then sketch my elbow as being up in that top right section. So there's a lot of steps, but we go in the same order every time to try to get those steps down pat. And then they want you to analyze your range of the function. So what is the only y value that I can never have? I can never have y equals 0, right? So y can never equal 0. And then this analysis, this is kind of leading you towards the end of the course because we're going to talk about limits. So this is the notation you'll see at the end of the course. But all this is saying is as x goes to infinity, so they're talking about this part of the graph. As this goes to infinity, what y value is the graph approaching? It's approaching 0. So the function is approaching 0. Then as x approaches negative infinity, so that's pointing to the left side, what's the function approaching? The function is approaching 0, right? They're both approaching the horizontal asymptote. Then they want you to look at these two arrows in the middle, and it says, as x approaches 2 from the plus side. So the plus side is over here as x gets more positive. So they're talking about this arrow. This arrow is pointing up towards positive infinity. So the function is approaching positive infinity. And then this says 2 from the minus sign. 2 from the minus sign, this is the left side of the graph. So they're talking about this arrow down here, and that's pointing towards negative infinity. So it's like instead of saying what's the right end behavior, they're saying as x approaches infinity. And instead of saying the graph goes up or down, they're saying, positive or negative infinity. All right, so that was one type of example. The denominator 1, and so we had y equals 0. I want to do one that comes out a little bit different. So I am going to skip ahead to number 5 and number 6. Because 5 and 6, that way it'll give you we did one example of each type together, and then maybe you could work through some of these on your own. All right, so number 5, I start back at the beginning. My first step, it's on the board, and it says we're going to plug in 0 for x. So if I plug in 0 for x, what do I get in number 5? 9, right? -9 divided by -1. So 0, 9, I can plot on my y-axis. All right, my x-intercept. So I'm going to look only at my numerator. What does my numerator factor into? It's difference of squares. Yep, so difference of squares, x minus 3 and x plus 3 are my factors. So I actually have two different x-intercepts, right? One of them will be at +3 and one of them will be at -3. So 3, 0, -3, 0, 3, -3. So I've got a lot of points on my graph this time. All right, how do I figure out my first asymptote? So I look just at my denominator. What will make my denominator 0? When x is 1. So my domain is x can never be 1, and my asymptote is x equals 1. And then I can dot that one in at 1. All right, and then my last step is comparing the numerator against the denominator. What type of asymptote am I going to have? So where's the bigger power? X squared over x. Yeah, so the bigger power is in the numerator. So I'm going to have to do division. I didn't really leave you enough room to do division on your paper, so I can just do it for us over here. X minus 1. Why don't you just talk me through the steps to get my slant asymptote? What do I do first? I put x squared here. Then what? X on top, because x times x is x squared. What goes here? -1x. I'm trying to get 0 x's, right? This is really x squared plus 0x minus 9. So I need +1x so that together I get 0 x's. So my last part of my asymptote is 1. So y equals x plus 1. If I wanted to find the remainder, I get -1, and then I need a total of -9, so I have a remainder of -8. So you could just write that your asymptote is y equals x plus 1, because we did the division together. And what does that look like? So that has an intercept at +1 on the y-axis, and it has a slope of up 1 over 1, down 1 over 1. So this is what a slant asymptote is going to look like when you graph it. That's why you need to know how to graph a line. I'm going to draw my actual graph maybe in a different color just so you can see it. So I've got these 2 points, in this region. So my graph is going to go like this pink section, and then my other part of the graph would go like this over here. So see how you're bending towards your asymptotes, cutting through your points? I don't have to plug and chug any points this time because all of my points are already fleshed out for me in the regions. They've got an asymptote on either side. Who wants to take a stab at my range? Do I have any excludable y values? Not really, right? So my range is actually all real numbers this time because this graph is extending up and down as far as it wants to go for the y values because of the slant asymptote. All right, last one together, and then I want you to work through, actually we might do 3 together, and then you can try, yeah, that'll be good. All right, we'll do 6 and then 3, and then you'll have like 3 or 4 to try on your own. All right, number 6, I chose this one because it's our third different type of horizontal or slant asymptote. So the first thing I always do is my y-intercept, I plug in 0, I would get 0, -7/5. So -7/5 is between -1 and -2 on the y-axis. So there's -7/5 because it's more than -1. All right, I need to do my x-intercept. So I'm going to set 6x minus 7 equal to 0 and solve for x. So what do I do to solve that for x? It's not going to come out as an integer. Add 7, divide by 6. So x is positive 7/6. So positive 7/6, comma 0, that's just more than 1. So on the x-axis, I go to just more than 1 and plot my point. All right, what about the domain vertical asymptote? What is going to make 2x plus 5 equal 0? Yep, subtract the 5, divide by 2, so x is -2.5. So my domain is x can never be -2.5. My asymptote x is equal to -2.5. And then I need to dot in -2. Yeah, because we have to subtract the 5 to the other side. And then I think you said positive 2.5, but you meant -2.5. All right, so there's -2.5. There's my asymptote. I can already see one elbow of the graph forming. I just need to figure out my horizontal asymptote. And so these are both linear functions, x to the first power, x to the first power, so they tie. So you strip the coefficients 6/2. So 6 divided by 2 is 3. So my horizontal asymptote will be at y equals 3. So y equals 3, looks like that. So you can kind of see this elbow must go there. And then I actually know for a fact that the other elbow must be up in this top left because I have no other x-intercepts. So it must be up here, but it's always good to plug in a point. So if we plug in like -3, that would tell us what we get. So my numerator would be 6 times 3, so -3, minus 7 divided by 2 times -3 plus 5. I put them in parentheses. 25 is the answer. So at -3, this graph shoots all the way up to positive 25. So it's way the heck up there. So it's going to be a really steep elbow in that top left corner. And what would be my range? So scanning, what y value can I never have? So my range would be y can never be 3. So one of those 3 questions, or 2 out of those 3 questions, would be your quiz on Thursday. So being able to do those 4 steps by hand to graph a rational function. And I want to skip up and do one more with you before you try. You'll have 4, 7, 8, 9. That's enough. So we'll do 3 together, because number 3 actually is going to have 2 vertical asymptotes, because I've got to factor the denominator and find my vertical asymptotes. So this one's a little bit more challenging. This one I probably won't give you on the quiz, because I don't want you to have to sketch 3 different regions of a graph. So the ones that you'll have to sketch have like a 2 different region, and that's it. So let's do this one together, just because it is a type of rational function. What's my y-intercept for number 3? Plug in 0, what would you get? 1 over -6, right? So -1/6 is really, really close to 0. So I have 1 in the numerator, -6 in the denominator, so the fraction -1/6. Do I have any x-intercepts? Can 1 ever be 0? No, right? So I have no x-intercepts. All right, denominator. What will make that be 0? So I need to factor that. So this is a trinomial, so I'm looking for the factors of -6, right, that add up to -1. So what 2 factors should I use? 6 and 1, 2 and 3. Which one do I want to be negative? My outer plus my inner has to add up to -1, right? So diamond would be -6, -1 on the bottom. This is where you need your factoring skills. No one knows? Are you doing it and just being silent? You don't know how to factor this trinomial? Yeah, it should be x minus 3 and x plus 2, because -3 plus 2 will give you the -1 that you need. So that tells me my 2 my 2 vertical asymptotes are at 3 and -2. So I have 2 different exclusions. X cannot equal 3 or -2. So x equals 3 and x equals -2 are 2 different vertical asymptotes. X equals 3 and x equals -2 looks like that. All right, and what would my horizontal asymptote be? Does the numerator or denominator win, and what does that tell you? It would be 0, because the denominator wins, right? So my range is that y cannot be 0. Actually, that might not be true. I need to look at the graph. My asymptote is y equals 0. This graph might do something funky when it cuts through its asymptote. So I wouldn't have you graph this one by hand. Once you have all this information, this is too complicated of a graph to do by hand. Oops. So on the test, I would just have you finding pieces of the answer, but x squared minus x minus 6. So because there's 3 different sections, okay, so this is a parabola down here. Sometimes in this middle section, the graph actually cuts through the asymptote, which seems weird, but it just has these 2 upper parts like this, and then this is kind of an upside down parabola down here. So I guess we could have assumed, if we had plugged in some points, we could have assumed that these elbows were here. Middle parts of graphs always do funky things. Sometimes they flip and go through the asymptote. So I won't have you graph a 3-part rational function without a calculator. And this would be still y does not equal 0. I was just thinking if it cut through the x-axis somehow, that would change the range. But all right, so you are going to try 4, 7, 8, 9, and I'll kind of walk around and help you and see where you're at putting this together.